a couple of other things, that aren't, just some basic, where am I? Slow down. Listen. Yeah, it's all this stuff. So anyway, there's other ways to do this. So we're going to start talking about a few of the algorithms that we can use. Linear classifiers, so like, I've been explaining things with linear classifiers, which is just like draw a line through your space, just be like everything down here is white, everything up here is black. Or you can use Bayesian things where we use probabilistic models to be like, it's, based on some features, I'm going to give it a label with certain kinds of probability. I'm pretty sure this is a mountain, but it could also be a dog, right? Things like that. A fancier one, support vector machines. So, I kind of got crap for this earlier. So like say you have an input space, and remember we were drawing that wonky like curve before around all those things. Well, so we take the features of our input samples, and support vector machines will transform them into another space. And so it says like, well, if you look at it like this, it's like not very easy. But if we transform the features of those, those examples correctly, we can actually put them in some kind of plane, and then it's like, oh, and then it's really easy to do that kind of thing. And so support vector machines, what they try to do is they try to find this plane or find some kind of line that maximally separates your multiple classes. Okay. There's a few other ones. Graphical model, you can't read this, but like say we have like, this is kind of like a, you would see this in if you were going to fix your car, it would be like, is there something wrong with, I don't know, can't even read this, like the lights or things like that. What is wrong? Like I follow a flowchart style kind of decision tree to like decide whether or not, what's actually wrong with my car, or, mark off random fields, which run away. All right, and then so there's more algorithms that are a little more inspired by nature, which we're going to be, this is neural nets are coming up. So we can do things like genetic algorithms where we do things like we mutate things, right? So like you take this blue one and you mutate him a few times, and you've got a yellow guy and a blue guy and a black guy, and then we do things, we throw away bad ones. This works a lot more like evolution. They're called genetic algorithms, and hopefully we eventually arrive at really good solutions spaces. Or you do things like this, things with neurons, things that like are modeled a little more on the brain and activation models of the brain. Okay, so I've been talking about how to, these algorithms and everything, but what we need to also talk about is the optimization of, while you're learning, how do you find out whether you're learning better or you're learning worse? Okay, so you can, the best way to think about it is like, a function that tells you how far away are you from like your optimal, or how far away are you from what you want.